This lecture is titled Law of Demeter. If we look at Wikipedia, we will see that the Law of Demeter, LOD in short, or Principle of Least Knowledge, is a design guideline for developing software, particularly object-oriented programs. In its general form, the LOD is a specific case of loose coupling. Okay, sounds great, but what does it really mean? A general formulation of the law is: each unit should have only limited knowledge about other units, only units closely related to the current unit. Or each unit should only talk to its friends. Don't talk to strangers. Great, sounds clear, but still not enough practical. The formal object form of the law can be summarized as: a method of an object may only call methods of the object itself, an argument of the method, any object created within the method, and any direct properties or fields of the object. Oh, at last, the practical meaning becomes clear. Moreover, all these guidelines in the end came to the following simple statement: don't talk to strangers. Another simple formula of this law is: use only one dot. Okay then, let's consider a practical example which was suggested long ago by David Bock as a great illustration of the problem. Consider the following case. Let's pretend that we should model the business relationships between a paperboy and a customer who wants to buy magazines. A paperboy rings the doorbell, a customer opens it. A paperboy somehow has to be paid and then hand over a magazine to the customer. Let's look at the code example which models the case. Here is a simple customer class which has first and last names, and it also has a wallet of type wallet. Here you can see the wallet class. It is extremely simple. It just stores the decimal value which determines the amount of money in the wallet. The client of the wallet API can add money to the wallet, can withdraw money, and check the current amount of money. Looks good and simple. It's just fine and should fit our needs. The last thing is to implement the logic of a paperboy. Let's look inside. The paperboy class exposes a single method, deliver magazine, which takes the cost of that magazine and the customer to which a paperboy has to deliver the magazine. Looks great. Let's look at the implementation. Paperboy just takes the wallet of a customer and then checks the amount of money. If there is enough money, the paperboy just takes the needed sum, otherwise a paperboy just goes away. Great, one would say. What do you think? Is it really great? If you think a little bit deeper, then you may come out with the idea that there is something strange in the fact that a paperboy takes the wallet of a customer in order to be paid. A paperboy has access to customer's wallet. What a nonsense! Would you be so kind to give your wallet to unknown paperboys? I doubt. So in this case the violation of the law of Demeter is obvious. The paperboy operates with a wallet through a customer. The first dot here in the code is when a paperboy takes the wallet. Then there is a second dot when he checks the amount of money in the wallet. The same case when a paperboy withdraws some money. To describe the problem more seriously, I should say that the main problem with this design is that the paperboy is being exposed to more information than he needs to be. All the problems are the consequences of this fact. So now these three classes are tightly coupled. If we change the wallet class, we may have to make changes to both of the other classes. By the way, if a wallet is null, then a paperboy will throw the null reference exception. So it might be that in the real-world code base, the paperboy will have to deal with it introducing null checks and as a consequence cluttering the code. So, how to fix the problem? In order to fix the problem, we can just model the real-world scenario. When a paperboy delivers a magazine, he just asks for a payment. Let's look at the improved design. Now the customer class exposes a public method named getPayment, while the underlying wallet object is now contained in a private field. No one except the customer has access to its wallet. The Paperboy now is forced to ask the customer to get a payment. Paperboy now doesn't have the rights and, by the way, the responsibility, as in the previous design, to fumble in the customer's wallet. So the improved design is better in 3 ways. It better models the real-world scenario. The Paperboy code is now asking the customer for a payment. The Paperboy doesn't have direct access to the wallet. Second, the wallet class can now change, and the Paperboy is completely isolated from that change. And the third, we're now free to change the implementation of the getPayment method. Okay, let's switch back to slides. To sum up, I want to say that the rule about the number of dots sometimes can be deceitful. The thing is that the law of Demeter is not about the number of dots. This law is about reducing the coupling and improving the encapsulation. When we are talking about data structures like data structures which are exposed by the Excel document, it's perfectly fine when its API allows you dig the structure of the document like this: Excel document.sheet.cell and so on. The same can be applied to Fluent APIs when each call returns an object, so you can build method chains. So, as always, don't treat rules as dogmas and try to understand the underlying meaning of the rule, instead of applying rules blindly. In the next lecture, we're going to learn the principle of least astonishment.